Welcome to qnawire.
So I see that you need help with this question, and it says a polymer is manufactured in a batch chemical process. Viscosity measurements are normally made on each batch, and long experience with the process indicated that the variability experience in the process is fairly stable with a standard deviation of 20. 15 batch viscosities measurements are given as follows. So there's 15. And so it's 720, 718, 780, 760, 750, 764, 756, 742, 745, 755, 749, 744, 745, 742, 795. And a process change that involves switching the type of catalyst used in the process is made. Following the process change, so then we have a process change. Each batch viscosity measurements are taken. So 740, 780, 734, 750, 780, 763, 740, and 770. So let me just fix this. It's a 5. Okay. And then it says, assume that the process variability is unaffected by the catalyst change. If the difference between the mean batch viscosity is less than 11, the manufacturer would like to detect with a high probability that the sample size would be required. What sample size would be required for each population if you wanted to be 95% confident that the error of estimating the difference in the batch mean viscosity is less than 6. So it wants it to be less than 6. So that's the standard error. Okay. And so we're given the standard deviation of 20 and the amount of numbers and we want to estimate the difference between the viscosity of the batch is 95%. So we're going to use a z-score for 95%. We're going to use a z-score of 1.96. So we want to figure out the sample size. And so what we can do is so it's a 95% confidence interval, and it has the of less than 6. Okay, so if it's less than 6, if I did 5 equals your 1.96 times your standard deviation of 20 over the square root of 15, or I'm sorry, over the square root of x. And so if I do 5 divided by 1.96, and so that's 2.551, that equals 20 divided by the square root of x. And so then I have the square root of x equals 20 divided by 2.551. And that is 7.8. And so I would have to square both sides. And so then x equals 61.46. So x equals 62. So the sample size would have to be 62. So I hope that this video helps. This is the math teacher signing out.